Hello class. So today we will be talking about current and electricity. So in the last class we have seen that uh, the properties of charges. We have seen the electric field, which is nothing but the force per unit charge. We have seen what is potential energy, the work done to bring any unit positive charge from infinity to certain to some certain distance r from your desired charge. So how much work you have to give, that work is being stored into the system, and that is called your potential energy. Now if you are bringing an unit charge, then it will be potential energy per unit charge, and that will be your potential only. So whenever we are talking about potential, the term, that means the charge we are taking is 1 and it is positive in convention. Convention means we have decided that, yeah, for our calculation we will take positive charge, because people don't want to be negative at all. Okay, if they are negative also, they want to show that they are positive, like that. Okay, so there are two parts. One part in electricity, or you can say electromagnetism. In the electro part, we have again two parts. One is electrostatic, where charges are at rest, and we have electrodynamics, where charges are moving. So I am just segregating them. So we have electromagnetism, electro, my God, okay, magnetism. So we have two parts in electromagnetism. We'll be talking later on. Electro part, we have electrostatic, and we have electrodynamics. Now electrostatics means where charges are at rest. So here we have read electric field, electric flux. You remember that we have taken the charge fixed at some point. So that means charges are at rest. So all the properties we have studied. Now in this chapter we will be talking about electrodynamics, when charges are moving or in motion. So this chapter will be dealing with the motion of charges. So whenever charges move, first thing which will come to our mind is why a charge will move. Now we know that if something you have to move, we need force. If it was moving automatically, then it's different. But then also, like someday, like whenever it was initiated, maybe it was at rest, but suddenly it's moving. That means something happened to that object which caused it to move. So when charge moves, then it's something, some reason to move. So what can be that reason? Now we know that one charge can interact with another charge. One Japanese can talk with one Japanese. An Indian cannot talk with them. Okay, like that, because we don't understand their language. Like that, positive charge can only interact with another charge. It may be negative, it may be positive, but only the interaction will be between charges. So if I have to give force, then there must be some charges, either positive one or negative one. Now let's say I have some positive charges here and I have some negative charges here. What will happen? They will come to close each other. They will come, like, so that means they was at rest, but because I brought one charge, and then, like, if I brought this charge, then the positive charge will move. So the cause of motion is actually electric field given by another charge. So if I have any kind of electric field, so who will provide the electric field? This, either of these charges will provide. So the electric field for a positive charge will be like this, whereas electric field for a negative charge will be like inside. So that means they will they both will provide electric field. So if I have some electric field like that, and I have a charge here Q, so how much force it will have? So let's say my electric field is E, which is a vector quantity. So what will be the force? The force will be E into Q, because we know that electric field is force per unit charge. So force for any charge is EQ. So if I put electric field and a charge, it will move. Okay. Achha. Now where it will move? Can it move in vacuum? Can it move somewhere else? Now you may be like you must remember this. I told you that proton cannot move. Like a nucleus, the whole nucleus does not go anywhere. The vacancy of electron does move. So uh, if I have some this kind of atom, and then let's say I had an electron here. This electron moved here, so that means there is a vacuum right now. Again this electron moves here and some another electron comes here, that means this vacuum will be here right now. So that means actually it seems that this vacuum has moved this side, right? So like that it happens. So these vacuums are taken as positive charge centers. Okay. So inside conductor electron moves. So we have three kind of materials. One is called conductor, one is semiconductor, we will read about this later on, and one is insulator. You will get this all in the book. Conductor means which can conduct these charges very nicely without any influences, extra influences. Semiconductor means they can conduct charges but under some certain condition, like you have to do something so that they conduct. Okay. An insulator, if you do something, if you like scold, whatever, it will not conduct. Okay, it will burn but it will not conduct. It is very stubborn, you can say. Okay. So insulator cannot conduct, conductor can conduct spontaneously easily, and semiconductor, it's up to you, like if you help them they will conduct, otherwise they will not conduct. Now we will be talking about conductor right now. So what kind of conductor? Conductor are generally materials like metals. Okay. Copper, gold is a very nice conductor. Silver is a very nice conductor. Aluminium is a conductor. Yeah, aluminium conducts a little bit. Aluminium conducts, though it is not a metal, but yeah, it's conducts. Uh, but copper is a very nice conductor, like that. Okay. Okay. Sometime air also conduct, but under certain conditions. We will come to that later on. Okay. Okay. So basically we'll be talking about very good conductors. We'll be seeing how they conduct. Achha. So let's say this is a piece of conductor, copper you can take. Now what we need them, like we need charges, right? Yeah, we need charges. So we have to give some charges. Let's say it has some charges. Okay, it has some charges. Now, why metals are having some charges, extra charges? Yeah, they have some extra charges which are loosely bound in their valence band. So, in the valence band, the outermost electrons are loosely bound, so they can jump one orbit to the neighborhood, neighbor atom. Okay, so they can jump and they can like conduct like that. So they conduct through the surface. So the conduction happen throughout the surface of the conductor. Okay, not through the inside. They always conduct throughout the surface of the conductor. So conduction happens throughout the surface generally. Now if I give electron, why they will go? You need something for them to go. You need some treat. So if I call my students for my tuition, I have to give some treat. Yeah, otherwise they will not come. So like that, uh, we need some positive charge to make them greedy, and they know, yeah, I know I need positive charge, so they will go automatically. Okay, so what else I need? I need some push also, so I will put here some negative charges even. So some cluster of negative charges will push them, you go away, you go away from my home, you go somewhere else. And the positive charges will tell, yeah, you come here, you are vacant, come here. So as a result, the electron will flow. So when the electron flow, we need some parameter which is called current. Current is defined as charge flowing per unit time per unit cross section. So let's say the current I want to find through this cross section. So I will say that how many charges passing per unit time. Okay. So you can understand that if I have a big broad, more cross section, broad wear, obviously there will be more charges, and as a result the current will be higher. And that is true. If we have a thin wear, the current will be less. If we have the big wear, like broad wear, the current may increase. It can handle a lot of current. Okay, but other factors are there. Okay, so current is charged by time. Now, current is having base dimension, you can say, elementary dimensions, which is called I, or somebody also take this as A ampere. Like you have M, L, T, same way you have A. We don't have a basic dimension for uh, base dimension for charge. We have a base dimension for ampere. The current is measured in unit of ampere in SI unit. Charge is in coulomb, and we can say coulomb by time, but we don't say, we say ampere. Okay. Now coming to some more things. Something is there called current density. So current density is generally, let's see, you have a conductor like this. So current density is written as, so there are volume current density, surface current density. So generally surface current density we talk about mostly. So surface current density, this is called sigma. This symbol is called sigma, small sigma. Achha. So sigma is current by area. Okay. So unit area, how many current, how much current is flowing, that is given by surface current density. Current density. Okay. Some more thing we will be talking about. Like we have a piece of material like this. How to give more excess positive and negative charges? That's why we use cell. So if we use this, which is called a cell, the cell has an inequilibrium between two charges, separate charges, like two different kind of charges. So in one of the side we have positive, and one of the side we have negative charges. but we have a separation between them and they cannot come together. So they has to go into some alternative direction. So that's why what happened, if we join them through a conductor, the electrons will go like this and the electrons will eventually come at positive. But conventionally what we take that the direction of current is opposite to the direction of flow of the electron. So I say that, yeah, people want to be positive, so they think that from the positive surface the positive charge centers are moving. I said that proton cannot move. Positive charge center means that those vacancies of electron. So these vacancies are moving in some certain direction, and people, for simplification, or you can say for their own calculation, they have taken as the direction of these positive vacancies as the direction of current. So in which way the electron is going, the opposite way we have to take the direction of current conventionally. So the current is flowing like this. Okay, fine. Now one thing is there which is called voltage. Now the voltage is actually a potential difference. So today I will be talking about this only, then the next we will discuss more. Acha. So what is our this potential difference? Okay, let's say you have a you have two rooms. In one of the room you have 3 people, one of the room you have 10 people, and here you are not having any home, going here and there. Where we will go, here or here? Obviously we'll go here. More vacant rooms are there. Now you know, more vacant spaces are there. You can see here that if you want to go here, then you need more energies to stay here. Why? Because people will punch you, people will try to kick you, that like you go away, go away. So you need more power to stay there. But if you stay here, you need less because already there is space, right? So the same happens with electron also. If you have any conductor like this which is connected to some battery, that means this is plus, so this portion, acha. Now one thing I will tell you, if a conductor is connected like this, so this point and that point are the same point only, because the current is going throughout this whole part, so it does not matter. Okay, so this whole point, so if this is plus, so this will be also plus. Okay, because the positive centers are here, and this is minus, so this will be minus as well. So one electron was there. He is thinking, now if I go to this part, I need more energy because there are repulsions, because there are negative charge. So if I go, I need more energy. So that means to stay here, the electron need, let's say, VB energy, and to stay here, the electron need very less energy, VA. Okay. So for electron, this. But I have said in the earlier lectures that we don't work with electrons, we work with positive charges, just for our convention. It's not logical or something, it is just like our convention. So instead of electron, we have to take here some what do you say, positive charge, test charge. Okay, so we will be working with test charges, positive unit charge. So now in this case, opposite will happen. To stay here in the A point, this positive charge required more energy because this side is already positive and there will be repulsion. But to stay here in the negative side, it needs less energy. So VV is much less than Va. So if one positive charge was here, like in Va, let's say some charges were there in Va. So when the charges was there in Va, it was having that energy Va, but now it wants to go into Vb post area. Why? Because it wants to go in a place where there are less energy, where he can throw some of the energy out. So now you can see that when this positive charge will come here at Vb point, then the extra energy which it was having will be released. So this extra energy is Va minus Vb. This extra energy is a work done by the positive charge who is moving. This work done is called potential difference or voltage. This is very important concept you have to learn. What is voltage? So voltage is the work done by any unit positive charge to go from one point to another point. So voltage will be like you have to take some reference that the voltage between B point and A point is this. The voltage between B point and C point is this. So for different points, the work done will be different, and that's why you have to use the reference. So this was voltage. Then it will come like the more things are coming, resistance and all those things. But today we will not go into very high topics. We'll be talking them later on. So today's class is this much. In the next class we will be talking about resistance. I will tell a little bit about resistance. Resistance you can understand from the word itself. Resistance means something that resists. So current is flowing through the conductor, you know that. But inside the conductor there are many things happening. There are very many molecules and everything are there, right? So when the electron try to go, or like you can say positive charge centers try to go, they what you say, they feel some resistance while going. So what happened while going, their energies are lost, like, or dissipated because of these collisions, you can say, okay, or the interactions between the like between the constituent of the material and the charge itself. So they will have a situation like that ki you are trying to cross a bogie of a train, sorry, a bogie of a train, and there are so many public standing here and there. So whenever you will be going, let's say you are going with full energy, okay, 10 joule energy, but while going you are colliding with him, then you are going out, and finally when you are out, you have 8 joule energy left. So 2 joule is lost here only. So like that also same thing happens for charges and the conductor also. So this energy which is lost by the charges due to the interactions, this energy is released as heat energy. So whenever the charge is flowing through any conductor, the conductor heats up, okay, and using this property we make heaters and lots of things, burners and all those things, okay. So we have some law, Ohm's law. We will be talking about that, a lot of that, but you know only this much ki, yeah, this potential, which potential difference which I was talking in the last topic. So I said that, yeah, potential difference is there because of this thing. But you think practically what happens, there is no plus positive charge like that. This we take because of our convention. Okay, but actually what happens, why potential drop is coming to show his like uh, part. See here, only electrons are there. Okay, the electrons are going like this. There are positive charge centers. Now the electrons are accumulating here. So let's say here we have 50 electrons. Because of the crowdness or the resistance in the conductor, let's say only 20 electrons has come this side, more are coming. So that means it's kind of you can say that we have a very narrow street and we have lots of cars. So you have seen some places where I'm just telling you where some national highway meets with a small lane. What happened in those cases? There are so many cars which were coming in the national highway because with high speed, but now only one by one car can go. So at last here one by one car will go, but here we have lots of cars. So this thing is happening because of resistance. This portion is like all the electrons are not able to go in that side so easily. So you can see there is a difference in the density of electrons. So density of electron is higher here, density of electron is lower here. Now let's say you have one electron here, or let's say we are conventionally talking with a positive charge. So positive charge is here. Now you say what will happen? Now what will happen? Uh, this positive charge want to go this side or that side? Obviously it wants to go in which side there are more electrons, it wants to go there. So in the right side there are more electrons, so it wants to go there. So that means the energy required for this positive charge to stay here is much lesser than the energy required for this positive charge to stay here. So again, the difference of energy is there, that is Va minus Vb, and that's why this positive charge wants to go this side. It wants to release some energy as heat energy, and it goes like that. So you can see that this rate of going also depends on this difference, right? If you give here more electrons 150 and here 20, it will go faster, like it wants to go more rapidly, right? So that means this current is having a relationship with the potential difference itself. Okay, and that's why we have Ohm's law, which we will be talking in the next class. So for today this much is there. I hope you will like this and you will read a little bit from the book. Reading from the book is must, and we will be talking in the next class. Till then, bye bye.